Chains of amino acids can fold into various structures. So here I have
This
an example
class
of
is
a
so
beta
hard.
sheet where
Everything
you
she
see a
teaches me
linear
just
folding pattern
confusing.
to make stripes of protein that form a coherent structure. The other secondary structure you can have is alpha helix. So that's when the proteins form into a twist, like a screw, and it's kind
Why
of
is
like
chemistry so hard?
that. It's hard to draw it in 2 dimensions, but it's
Everything she teaches me just confusing. I really just want to know why I'm sick. I wish she could actually show us what it looked like instead of drawing those things. Where am I? What is this place? I have a question for you.
Yeah,
I really want to know why I'm so sick.
let me show you.
Wow, this is amazing. Where are we?
Well, you said you wanted to know how you got sick, so now we've shrunk down and we're inside of your nose. And this giant purple thing behind us is one of the cells of your nose.
What are these long chains?
Well, these chains here, these are sugar chains that form the mucus that protects your cell from invading viruses. And you can see that the sugar chain is made of a lot of individual molecules of sugar that stack onto each other. So look up behind you. Do you see that big protein there?
Oh, right here?
Yeah. So that is a viral protein that's an enzyme. And this enzyme is what's responsible for the virus to invade the cell by cutting up the mucus so that it can get closer to the cell membrane.
And what are these circle things?
All the little circles represent different atoms.
Oh.
So see how the enzyme has a pocket here?
Oh, yeah, right there.
This pocket is the active site, and that's where the sugar gets inserted and then the enzymatic reaction can happen so the sugar gets cleaved off.
Oh.
So see what happens if you pull the enzyme close to the sugar chain there.
Wow! Oh my gosh! Does a purple star stand for a chemical reaction?
Right, exactly. So for the virus to infect the cell, it needs to get really close to the membrane. So it has to do that same reaction a bunch of times.
Okay.
There you go. And so now, this is bad for you, but good for the virus. It's almost close enough to the cell so that it can get in.
I can see that it keeps getting shorter and pieces just keep falling away.
Yep.
Wow. So is this how I get sick?
Exactly.
Wow, this virus protein has so many atoms in it. How do they know how to assemble themselves?
There's another way to view this protein. If you swipe left on your touchpad, you can see another view. Now here you see all these rainbow strands. The protein's actually made up of just one single continuous strand. Can you find the ends of the strand?
Well, one is right here,
That's right, there's a blue end on your side.
and the other is right here.
Exactly, the red end is over here. And you can see, based on the way the strand folds, there's different structures. So these long arrows are the beta sheets, and there's also alpha helices, which are the corkscrew structures. Can you find some alpha helices?
1, 2, 3, 4.
Right, there's 4 alpha helices over on this side of the protein. Do you want to see another view of the protein with more molecules in detail?
Sure.
So swipe left again.
Wow, thousands of atoms, just like the first one, just smaller.
Exactly. So now we can see the individual side chains of the different amino acids. There's 20 different amino acids, and you can see all the different structures. So do you see the double ring structure up here?
Double ring. Is it right here?
Yeah, exactly. That's a tryptophan amino acid.
And what about this one?
That's a lysine.
Wow. What about this green one right here?
That's a phenylalanine.
And this one?
That's a isoleucine.
What about this one?
That's a...
Finally, I know how I get sick. The virus can't get past the mucus chains on the cell surface, but it is cunning because it has proteins at the tips. The proteins chop off the mucus chains, sugar molecule by sugar molecule. And then it can fuse with the cell membrane and enter the cell. But how do you stop this from happening?
Scientists have developed drugs that can bind in the active site so that the sugar molecules are unable to fit in. That way, the flu virus has no chance of entering the cell. But that's the lesson we'll talk about next time.